Thank you very much.
Mm. Okay, thank you very much. So we need to go to the fourth presentations. The title of the fourth paper is OA-GAN, Overfitting or the avoidance method of GAN of sampling based on xAI. So the presenter is Gina Kim, coming from Myeongji University, Korea. Gina Kim, have you prepared your presentation? Could
Ah,
you share the monitor and
okay.
yes, I see. Yeah, I'm able to hear your voice.
Ah, see
Okay,
presentation.
yes, yeah, it's good.
Ah,
PPT
okay.
is okay.
Okay. Uh, Hello. Thank you for being here. This is Yakim, and I am in the Master and PhD combined course of Myeongji University, Department of Information and Communication Engineering. The topic of my presentation today is OA-GAN, oversampling avoidance method of GAN, oversampling based on xAI. I will divide my presentation into 5 parts. First, I will discuss introduction. Next, I will talk about related work, proposed OA-GAN, and simulation results. Finally, conclusion we are going to look at. The presentation will focus on proposed OA-GAN and simulation results. Let's begin with introduction. Uh, we already know why overfitting occurs in machine learning, and we use data oversampling to solve it. So we have to do data oversampling, and the method is data augmentation. We will look at this deep learning approaches, GAN data augmentation, in this presentation. I have considered does GAN have no overfitting. This is a visualization of the filter on the discriminator. On the right is the filter of the learned model. I believe that the discriminator is overfitted. The reason for this is the filter of the learned discriminator has been trained too much the appearance of a particular class. In this presentation, I'd like to propose on training method for this problem. And this section are related works for that. My paper motivation is GAN and TCGAN. I have a look at overfitting of discriminator, and we use the xAI method to confirm it. There are two alternatives, rhyme and sharp. Among them, I used rhyme, and sharp is being prepared in future work. Now, let's move on to propose OA-GAN. This learning process may avoid overfitting the discriminator. I'd like to explain on this algorithm. In order to use the method proposed in this presentation, half of the steps must be learned. One reason for this is sometimes it is impossible to run if limited from the beginning. Another reason is that if the discriminator does not run, all images can be recognized as fake images. Next, set conditions for running restriction. This is called a threshold, and we will use the average of two losses. The first loss is that the discriminator determines the real image, and the second row determine the fake image. Set the average of the two rows calculated as such to threshold. After half of the step, only run when the threshold value is greater than 0.5. The value of 0.5 is set based on the value at which the discriminator is most optimized. Value less than 0.5 are judged to be overfitting and are not reflected in the running. This is a flowchart of the learning method proposed in this presentation, and it is our view that A, explain, and B, threshold change. Next, simulation result. The following figure illustrated the result using a small image. The discrete results show that all area of the image and active. The discriminator runs the features of the image, which is used as a OR because the features runs are too large for the overall image size. This figure shows the running results of image size 64. The explanation is clearly divided compared to the previous 32 size image. However, the fake image is still active throughout the area. And this figure is the running result of 128 size image. The parts that are more clearly reflected in the results than the previous two size images are divided. Therefore, we can see that xAI itself needs to be somewhat larger to run well. We can see that the more we adjust the threshold, the more area discrete the area changing. However, when the threshold is 0.5, we can see that the area we need becomes the negative area. This figure illustrates the discriminator according to the threshold. In A, we will see that the area explained vary depending on the threshold. B show that the estimated area is best reflected when the threshold is 0.5. Okay, today I have shown you the paper that OA-GAN. I'd like to recap the main points of my presentation. First, I covered the problem of overfitting xAI discriminator during the data oversampling method. Then we talk about running process to avoid overfitting by restricting the discriminator. Finally, we use the value called threshold, indicating that the value is 0.5. Okay. Thank you for very much for your attention.
Thank you for your presentation. Yes. Okay. I have one question that what is the relationship between Lime and Shark? Could you give us a little bit explanation between Lime and Shark in the introduction part? What's the difference? Why is the difference between
Uh,
two algorithms? Could you just give us the difference in the introduction part? You show me Lime and Shark introduction part around the page 7A.
okay. Uh, this page.
Yes. What is the main difference between them? The local interpretable model exploration and sharp pre-additive exploration. So there's some difference between them, right? Just I'm asking that if you have any information, just show me that.
Okay. Sharp is show the weight for uh,
Mm,
area of interest. This area and this area. And Lime. Lime show the 그 affecting area. This area is right area, and this red area is negative area. So sharp is sharp output come in value is int and float value. But line is image output.
Okay, so thank you for your presentation and the answers for my questions. Okay, thank you very much.
Okay, thank you.
Yes, let's proceed with the fifth one's presentation. The title of fifth one is Optimal Analysis Management